Hello, everyone. This is Mr. Win. If you're hearing this, I am not in class, so I'm going to be teaching you with um, this video. Um, I'm probably off somewhere getting my vaccine shot, probably crying like a baby, but that's what I'll probably be doing instead of being here teaching with you. So, of course, I'm going to be teaching you here instead of here on YouTube rather than in person. So let's get into it. So today what we're going to talk about is equivalent expressions. Equivalent expressions. I think everybody's heard of this before. Equivalent expressions. Well, we've seen a lot of this recently. Equivalent expressions. So when we do the distributive property, this is the last thing we learned. So let's just say, for instance, we have 8 times I don't know 4 times oops 4 plus x. An equivalent expression is something that's completely equal to this. So that's going to be, if we did the distributive property, that would be 8 times 4. So this is equal to 8 times 4 plus 8 times x, which gives us 32 plus 8x. Okay, so this here, 32 plus 8x, is equivalent to 8 times the sum of 4 and x. These two, whoops, these two are equivalent expressions. So this is an expression, and this is an expression. These two are equal to each other, thus the equal sign, right? So we've seen equivalent expressions before. The other thing that we talked about last time, this is using the distributive property, of course. Let me put this in black. This is the distributive property. Now, the other thing that we talked about last time was factoring. If you guys recall factoring. So let's just say, for instance, we have two numbers. Let's say 48 minus, I don't know, let's say 16. Let's say, for instance. So if I were to ask you to factor, you have to take out the GCF. Okay, so we have to find out what the GCF is, which means we do our upside down division to find the GCF. So we have to look at 48 and 16. We have to think of what is a number that we can divide both 48 and 16 by. Well, if you don't know what it is, the highest number, you can go with the smallest number, 2. Okay, 1 doesn't count. So 48 divided by 2 gives you 24. 16 divided by 2 gives you 8. Notice that we keep the same sign. This is subtraction, and this is still subtraction, right? So now we look at 24 and 8. What is one number that we can divide both 24 and 8 by? Well, we can go with 2 again. So that becomes 12. This becomes 4. Now let's look at the 12 and the 4. What is one number that we can divide both of them by? Well, we can do 4. So 12 divided by 4 gives me 3, and 4 divided by 4 gives you 1, right? So this is my GCF, okay? The product of these three numbers. So that would be 16. 16, and these are the leftovers here. I'm going to put this in red here. The result here, 3 minus 1, those are the leftovers. You can't find a single number that you could divide both 3 and the 1 by. So you kind of just drop them inside here. Okay, what does this have to do with equivalent expressions? Well, what we began with was 48 minus 16. And 48 minus 16 can be factored into 6 times the difference of 3 and 1. Okay, they should be exactly equal to each other. Well, let's see. 48 minus 16 gives us 32. 16 times 3 minus 1 is 2, so 16 times 2 gives us 32. So they're equal to each other. So this expression and this expression are equivalent. They're equal. to each other. So we're only interested in equivalent fractions at this time, okay? Things that are equal to each other. Okay, so that's a quick rundown, a quick review about what we did uh, early this week. I think on Monday and Tuesday. Not Monday. This is what we did on Monday. We're going to take this a little bit further. Okay, so I am going to switch to a new page. Let's see if I can't make this a little bit smaller. This is a lot of real estate here. Oops. Okay. Okay, so let's take a look at this. So again, we're going to be talking about equivalent expressions. So basically two expressions that are equal to each other. So let's take a look at this. What happens if you have this expression? Let's try m plus m plus m. Now, what we're going to do is we are going to simplify this expression into something a little bit neater, okay? So if we have three m's, can we write 3m? Because it's 3 times m. An example of this that you can possibly relate to better is if I had numbers. So I'm going to put this over here. Let's say you have 4 plus 4 plus 4. Now remember with repeat addition, it's exactly the same thing as multiplication, right? So if you have 3 4s, isn't that 3 times 4? It's the same thing, right? These are the same thing. Only you can multiply 3 times 4. You can't multiply 3 times m. Because again, like with the discussion we've been having for a while now, you can't multiply 3 times m. Well, we can't do anything else with 3 times m because we don't know what m is, right? If we knew that m is equal to 4, then we could do this. That would be 12. We just substitute in the 4 for the m. But we don't. Okay, so we leave it as 3m. And this is simplified. Okay, that is simplified. Okay, so the whole idea of simplifying an expression is where you take something that is a little bit complex and you turn it to something that cannot be reduced any further, that cannot be simplified any further. And when I say simplify, what I mean is there's nothing that you can add, there's nothing that you can subtract, there's nothing that you can multiply, and there's nothing you can divide. Okay, it's as simple as you can make it. Let me give you an example of what I mean. So let's just say, for instance, I'm going to give you example 1 here. Let's just say, for instance, you have this expression. 14y plus x plus 22y. Now this is a problem that is found in the book. I think in example 3. And I think this is a pretty good example to start off with. Now let's take a look at this. Let's backtrack a little bit to this problem. The only reason why I can add all these m's together is because they're all the same. If they were different in any way, I won't be able to add them. So let me make a little bit of room. So let's just say, for instance, just as for the sake of argument, if I have m plus x, now suddenly I don't have 3 m's anymore. How many m's do I have? I have 2 m's, so you can write 2m. But what do we do with this x? Can we add the x to the m? I would say no. You can't add the x to the m because x represents a single number and m represents a single number. M is being added to each other. So you have 2 m's there. But x, you have only one x. So what you have to write is 2m plus x. You don't do anything with this x. And you don't do anything with this m because these are simplified as well. This whole expression is simplified. Because again, you don't know what m is equal to, and you don't know what x is equal to. So you can't add them together. Okay, two different letters. Now when you look at this example, the same thing is true. Okay, so everything's being added, right? So you have 14y plus x, and then you have 22y being added to that. Now, can you add the 14y with the x? No, for the same reason why we can't add the m and the x together. So you could say that there are two m's, and then we add that an x to that, but we can't add the two and we can't add the 2m and the x because they're different variables. Same thing's true here. You can't add 14y and the x because they're two different variables. However, you can add, well, once we decided that we can't add these two things together, the 14y and the x, once we decided that, we can drop the parentheses. Another thing is that we can only add something called like terms. Let me write this on the side here. Like terms. Now, what do like terms mean? And I'm going to repeat myself here again. You can only add things that are the same, right? You can only add like terms. But what are like terms? Like terms are, let me increase the size of this. Like terms are terms that have the same exact variables and exponents. Okay? You have to have exactly the same variables and exponents. The numbers, the numbers in front of the variables, they can change. But the variables have to be exactly the same with the same letter and the same exponent if that variable has any exponents. Like right now, you have 14y and 22y. These two could be added together. Now, uh, there's more to this, but let's start with this. This is what I want you guys to do, okay? And again, the good thing about this being recorded is that, you can rewind it or repeat it as much as you want. I don't know why you want to repeat and listen to me like 3 or 4 times, but you can if you want to. So this is what I want you to do. I want you to put a box around different terms. So this is one term, okay? Terms are separated by addition and subtraction. But look what I'm going to do next. I'm going to box this next term. Notice that I also included inside the box the addition sign. The reason why I do that is because I want you to think about this as positive x. Okay? And I'm going to box this as well because I want you to think of this as, again, oops. I want you to think of this as positive 22y. Okay? I want you to think of it as positive 22y. Okay? Now, the reason why I want you to think of this as positive x and positive 22y is because everything here, everything inside these boxes can be added to each other only if they're like terms, if the terms have exact same variables and exponents. Now, the only two that we can add together is this one, 14y and 22y, because they have the same variables, y and y. So if you have 14 plus 22, 14y plus 22y, that gives us 36y. Okay, we just added them together. And we can only add them together because they're like terms because they have the same variables and exponents. So once you add them together, they're done. The only thing that's left over is x. And again, like we keep on talking about, we can't add them together. We can't add x and y together, so we leave them as they are like that. 36y plus x. Okay, or if you prefer x plus 36y, you can change the order because of the commutative property. I actually prefer this way, the one on the bottom here, because x goes before y. That's just an alphabetical thing. Okay, um, let's do another one so we can uh, see this a little bit better and for you to get used to this. So let's go with example 2 here. Okay, so let's just say, for instance, we have 8x plus oops, plus 15y minus 3x. Okay, so the very first thing I want you to do is I want you to box all the terms. Okay, I want you to box all the terms. So the first term is just 8x. And because there's no sign in front of the 8x, we know that that's going to be positive 8x. The next term we box is 15y, positive. Remember, box it with the addition sign because the addition sign, you can think of it as just positive because it's a positive number, positive 15y. Okay, now the last one is now negative 3y. Negative 3x. And again, instead of positive, like this one, the addition here becomes positive 15y. Just like that, this subtraction sign now makes it a negative 3x. Okay? Now, what are the like terms here? Well, the like terms are 8x because they're, uh, the, sorry, the like terms are 8x and negative 3x. The reason why is because the variables x and x are exactly the same. So we could just put them together. What is 8x or 8? Yeah, 8x minus 3x. Just look at the numbers. 8 minus 3. That gives us 5. That gives us 5x because 8 minus 3 is 5 and you just drop down the x. Okay. Now what we have left over is the 15y, the positive 15y. So because it's positive, you add 15y. And that's our answer. Okay? So that's positive 15y. Let's do some more with the, the distributive property. Hopefully you guys understand what this is about. Because if you think about it, all we are doing is simplifying, making something difficult to something simple. Okay? Not really difficult, just something that has a lot of parts and we're turning it to something with less parts. Right? So if you have 8x plus 15y minus 3x and you want to simplify that, you can combine the like terms. Okay? So if you combine like terms, well, the like terms here is 8x and negative 3x. Those two can be put together by adding. Okay, so 8x plus negative 3x gives you 5x. And now suddenly you're simplified. You've simplified the problem. Okay, you can't go any further because again, you don't know what x is and you don't know what y is, so you can't add them together. You just leave it the way they are. Okay. Okay. Let's take a look at the distributive property again. How does this apply for the distributive property? I think we saw an example previously of how the distributive property works, right? This is what the distributive property looks like. Now, let's take a look at what that means if we have a lot of variables. So let's just say we have 7 times 3x plus y. Okay, this works exactly the same way as the distributive property before. We multiply this number, the 7, the number that's outside of the grouping symbol, the parentheses, 7 times the first term, which is 3x. So we have 7 times 3x. Plus, we'll leave the operation there, addition. Then we have 7 times y. It's exactly the same. But now we have, what, two different variables, right? But it works exactly the same. 7 times 3x is just 7 times 3 and add on the x. So that's 21x plus, and 7 times y is just 7y. And that's it. That's all there is to this. So we know that 7 times the sum of 3x plus y, 7, is equal to 21x plus y. Now remember what I said about simplifying? Here, let me put this in a text so you can see it. How to simplify expressions. Well, let's say algebraic expressions to be more precise. How to simplify algebraic expressions. At the end of the day, when you've done everything possible, this is how you know whether or not you've simplified the algebraic expression. There is nothing you can add, subtract, multiply, or divide. There's nothing that you could do with that. Okay? If there's anything you can add it. If there's anything you can subtract it. If there's anything you can multiply, and anything you can divide. Now, when you look at this problem here, we have 21x plus 7y. There is nothing you can do, nothing further you can do. You can't add anything. You can't add 21x and 7y. You can't add them. You can't subtract them. There's nothing you can multiply. There's nothing you can divide. So this is done. That is simplified. But when you look at this over here, you have 7 times 3x plus y. 7 times the sum of 3x and y. There's definitely something you can multiply, right? And that's what the distributive property is about. You're multiplying 7 times everything inside this quantity. Okay? And once you've multiplied it, you get 21x plus 7y, which means you're done because there's nothing you can add, subtract, multiply, divide. Okay? So this is with distributing. This is using the distributive property. And now let's take a look at it factoring. And of course, I just want to say this. We're dealing with, again, equivalent expressions. This expression is equivalent to this one because they're equal to each other. Okay, now let's take a look at factoring. Again, let's put this in blue. Example 4. So let's just say we have 27x plus 18y. Now, when I ask you to factor this, what I'm asking you is to factor out the GCF. Okay, factor out the GCF. So first you have to find out what the GCF is. Now we go through the same process that we've been doing. Look at 27 and 18. Ignore the letters for the moment. The letters, the variables, they're just going to go along for the ride. What we're going to concentrate on is the 27 and the 18. What is a single number that you can divide both 27 and 18 by? Well, we can divide by 3. 27 divided by 3 gives us 9. And again, tag on the variable because the variables are just along for the ride here. We're going to talk more about the variables later if we need to, but for the moment, I don't think we do. So the variables for now are just going along for the ride. What is 18 divided by 3? 18 divided by 3 is 6. And again, the y just along for the ride. Now we're going to look at the 9 and the 6. We're going to find out a single number that we can divide both of them by, and that's going to be 3 again. So 9 divided by 3 is 3, and again, drop down the x. 6 divided by 3 is 2, Drop down the y. Now take a look at the 3 and the 2. Is there a single number they can divide both 3 and 2 by? No. So we stop there. We know that we have 3x plus 2y. That there goes inside the parentheses. Now all we need is the GCF. The GCF is provided for us by these two numbers, 3 and 3. The product of them is your GCF. That's 9. So right there. Correct that arrow. Okay. That's our GCF. Okay. So the GCF is 9, and these two numbers, these two terms, give us what's inside the parentheses, the grouping symbol. And that's it. That's factored. This is factored form. Factored form. And factored form is not simplifying. You're doing the opposite of the simplifying. So when you look at the very beginning here, the very beginning, this is not, so this is already simplified. This is already simplified. 27x plus 18y, that's simplified because there's nothing else you can multiply. There's nothing you can add, subtract, multiply, divide, right? When I ask you to factor, what I'm asking you to do is transform the simplified form into a form where you have to multiply two things. The 9. Now let me put the screen. So you have two things now. You're going to multiply the 9 times this. See how the factored form is like the backwards version of the distributive property? The distributive property begins with two things that need to be multiplied. And then you end up with something that's simplified, 21x plus 7y. Over here, you begin with something that's already simplified, and you transform it to something that is no longer simplified. You have two factors, 9 and 3x plus 2y. That's what it is. Okay? I want to talk to you about a few things now. Since we already did all this work, I want to talk to you about definitions. Okay, because I want to be understood when I talk to you about these things. You've heard these words a lot already. It's only now that you need to understand what they mean. Term. Okay. We talked about term quite a lot already. Let me see if I can't make this larger. Okay. We talked about terms quite a lot. What is a term? So this is these are parts of an expression, an algebraic expression that is separated by addition and subtraction, or it can stand by itself. So let me give you an example. Just to make things super clear, put in blue. So if you have 4x plus 3y, you have two terms. The boxing thing that I asked you guys to do, how I asked you to box this and then box this if you want to simplify, what you're really boxing are the terms. Okay, so this is a term and this is a term. You have two terms. Okay, and again, the addition, that's very useful to telling you whether a term is positive or negative. Okay, so now you have positive 4x and positive 3y. So these are two terms. Okay, so if I were to ask you to list out, tell me how many terms you have for 4x plus 3y, you would say you have two terms. What are the two terms? Well, for the terms, what you have is 4x, comma, 3y. You have two different terms there. Okay. When I say also that it can stand by itself, let's just say you have 3x. Okay, this is a term. This is one term. It's not separated by addition and subtraction because, well, you don't need it to. It can just stand by itself. That's one term. Okay. Now, if you were to say string together 3x with a whole bunch of other terms, yeah, you would need addition and subtraction to do that. You would say, I'm going to make up something random here, plus 8y minus 15z. Now suddenly you have three terms. Because again, if we were to separate this, oops, if we were to separate this into our boxes, see, now we have three of them, three terms. Okay. But if we didn't, if we just left it by itself, just 3x, that's just one term. Okay, just one term. Now, the next definition that we need to talk about, coefficient. This is the numerical part of the term. What does that mean? Let's go back to 3x again. 3x, the numerical or the number part of the term. If 3x is the term, what's the number part? It's just a number in front of the variable. This is the coefficient. It doesn't matter how complex it looks. Here, let me give you something that looks really complex, and I'm going to ask you to identify the coefficient. So I'm going to say 8 times x squared times y to the third power. That looks kind of really difficult, right? But the coefficient is the numerical part of the term. It's usually in front. Let me put that in there. It's the number in front of the variables. Variable, well, one variable or many variables. So if I were to ask you what is the coefficient for 8x squared y cubed, you would just say 8. That's the coefficient. 8 is the coefficient, and 3 is the coefficient over here. See, it doesn't matter how complex this looks. If I ask you for the coefficient, that's just the number in front of all the variables. Okay? That's what that is. Okay. Two more things. Constant. Now, I'm not sure I'm going to be quizzing you specifically on this, but this is something that you need to know because I'm going to refer back to it again and again. Constant is just a number by itself. So, this whole time we've been talking about, 3x, 4x, 8x. So something with variables, something with a number and a variable, right? A constant is just a number, any number. So if you have, say, I've been using 3 too much. Let's say 18x minus, well, plus, let's do plus. 18 plus 5. Okay, and then we separate it out. What's the constant? That's the constant. 5, positive 5 is the constant because it's just a number by itself. There's nothing attached to it. There's no variables. There's no series of variables with an exponent. It's just a number, as simple as it can be. Okay, this is your constant. Just a number. Can that number sit by itself? Yeah, it can stand by itself. So let's just say you have the number 7. Is that it's a term, but it's a constant, right? Constants can also be terms. So you have 7, you have 5, just whatever is a number, it's just sitting by itself. It can't have a variable with it. It's just a number by itself. So that's a constant, right? This is also a constant. Just a number. That's all it is, just a number. Okay. And the last one thing we need to talk about is something that I just want to reinforce here, like terms. Like terms are terms with the exact same variables and exact same, no, sorry. Yeah, terms are, like terms have exactly the same variables and exponents. I don't think you have to worry about the exponents for a while, but just make sure the variables are exactly the same. Okay, just like 8x and negative 3x are like terms, 14y and positive 22y are like terms because they have the same variables. Now the numbers in front of them, the coefficients, can change. They can be different, but the variables can't be different. Okay, so let's do a word problem. Let's do a word problem. Okay, we're going to do one word problem and then we're done. Let me type this out. Yeah, let me type this out. Gabrielle, oops, no, make this 22 size. Okay. Gabriella is X years old. Her sister, Felicia, is 6 years older than she is. Their mother is twice as old as Felicia. Their aunt, Tanya, oh goodness, I should probably break this up some. Their aunt, oops, their aunt, Tanya is X years older than their mother, right? And simplify an expression that represents Tanya's age in years. Okay, so this is how we do this. We're going to break it down, okay? Let's start from the very beginning. So Gabriella is X years old, right? Do you know how much that is? No, because they said they give us the variable X. So X years old. Her sister, so this is Gabriella's sister, Felicia, is 6 years older than she is. Okay. Okay. Her sister Felicia is 6 years older. So let's do it like a bit of a chart here. So this is Gabriella. Felicia is 6 years older than she is. So that's Gabriella plus 6. Their mother is twice as old as Felicia. So this is mom here. Is twice as old. So we have Felicia's age. I'm going to multiply that by 2 because that's how old mom is, right? Their aunt Tanya is X years older than the mom. Okay, so this is mom's age is twice the age of Felicia, and is X amount of years older than the mother. Write and simplify an expression that represents Tanya's age in years. Okay, so basically what we will have to do is simplify this. We wrote it out already. So we wrote out Tanya's age. This is Tanya's age right here. But we need to simplify this. Okay, does that make sense to you guys? I hope it does, because I can't get your responses because I'm recording this. Anyway, so we have 2 times the sum of x and 6 plus x. Okay, so right now we can't add x and x because we have to multiply these two. We have to do the distributive property. Whenever you see a parentheses, okay, whenever you see a parentheses, you you can't add and subtract anything until you get rid of those parentheses. And usually what the parentheses mean is there's something you have to multiply first. Okay, there's something you have to multiply before you can drop and make that parentheses disappear. So in this case, you have to multiply them using the distributive property. So 2 times x gives you 2x. 2 times 6 gives you 12. Okay, now what we could do, there are no more parentheses, there's no more grouping symbols, right? Because I did the distributive property. Now is the time where you can box things out, separating the terms. You couldn't separate the terms up here because you had that parentheses, right? That tells you to do the distributive property. But now that you've done the distributive property, you can box things out, and now you can add the like terms. Well, what are the like terms? The like terms are something with the same variables. We have 2x and we have x. Now, if you guys don't know, any variable always has a 1 in front of it. If it doesn't have any number in front of it, there's always a 1. Okay, so be aware of that. So x is the same thing as 1x. Y is the same thing as 1y. So in this case, you have 2x and a 2x plus x. Now this is not just x, this is 1x. So what's 2 plus 1? Well, that's 3. So that's 3x. So that's been added together and you have 12. So this is Tanya's age simplified. So that's your answer. Okay. So that's it. That's about all I have for you for today. Um, hopefully all this makes sense. And yeah, that's it. I'm gonna give you guys homework and look for it in the what should we call it, in the Google Classroom. All right. Have a good day. Bye. Oh, let me go ahead and write the homework assignment, just since we're here anyway. Homework is page 499, 499 through 501, and I want you to work out the odds. Okay. I will see you next week.